All right, we are back here at First Python Notebook, and I am again Ben Welsh, live from Manhattan, USA. Here in our next chapter, we're going to move beyond doing data analysis with sort of built-in basic Python code, and we're going to step it up and get more sophisticated by introducing a new tool. This tool is called pandas. You can see its webpage right here on my screen. And pandas is a free and open source extension to the Python programming language that just makes it easier to do data analysis. It was first invented by a guy working at an investment firm, but it's gone on to be used not just in the finance industry, but also in the sciences and all over academia, and especially in the world of journalism. At least for our purposes, that's most interesting. And it is, at its core, using a metaphor at least, a sort of tool belt. It's dozens and dozens of Python functions, much like the simple sum and len function we learned in the last chapter, that make it easier for you to get your hands on data, to manipulate it and move it around, to analyze it, to aggregate it, to filter it, to sort it, to rank it, to do all the things that go into a data interview and better understanding your sources, but also to a data analysis, right? That ultimately outputs a finding that you're going to publish. And so almost strictly for convenience at making working with data easier, many Python computer programmers prefer to use pandas whenever they're working with a table of data. And so because it's not built in with the Python programming language, it often is not available to you when you first install Python on your computer. And it's not the only program like that. If you go to a site that's known as the Python Package Index or pypy.org, you will find hundreds of thousands of extensions to the Python programming language that other computer programmers, oftentimes for no pay, mostly as volunteers, have put together and packaged for redistribution for other people to make it easier for themselves and everyone else to just get stuff done with the Python programming language. And there's extensions that makes it easier to scrape web pages, to download data. Jupyter itself is available here as a package that can be installed via the Python system. And of course, if we search for it, we can find pandas, there's pandas too, which is a slightly different thing. But if we search here, we can find pandas. Has its own page in this kind of phone book or directory of free and open source Python tools. And any Python tool that's available inside of pandas can be imported into a Jupyter notebook to be used alongside regular Python code. And before it can be imported, it has to be installed because these programs are not on your computer to begin with. And so the first steps of working with a third-party program like pandas in your Python environment is to check if it's installed, and if it's not, to add it in there so then it's available. So we're going to do that next. Let's all go back to our Jupyter notebook that we left behind in the last chapter. As you can see here, scrolling up and down, there's all the kind of experimental nonsense I had us working on last time to learn some of the basic fundamentals of Python. I'd like to delete all that and let us just kind of start again from the top. Now, there's more than one way to do this, as we covered. You can click on a cell and you can hit the trash button here on the right? Or you can click on a cell and hit the cut button in the upper right. That also works. You can click one cell, hold the shift key, or I thought you could, maybe you can't. Huh, busted. But there's ways to select more than one cell. But one thing I like to do is just click right here on a cell near the top and just repeatedly hit the cut button to kind of zero out everything that's there. So I'm just down to my single cell and I can kind of start over with the blank page. We could have kept writing further down the notebook. There's nothing wrong with doing that, but things can get cluttered. Errors can be introduced, and you can end up with sort of a bit of a doodly page full of curly cues and experiments. And it's often nice to just kind of delete what you have and start from the top. Another alternative, of course, would be to just start a new notebook with our File New button, right? Entirely up to you, but I'd recommend we find a way to start over at this point. So Python has a built-in function, just like len or sum that we saw before, that gets to come out as a pretty green word. And it's a sort of magic term that allows you to import an outside package of Python code for use in your current program. So to import pandas, which was its name on the Python package index, into your notebook, you simply type import pandas. If we do that and hit play, you can see that the little box here that runs whenever you execute code has a star in it. That means that your computer is thinking, that it's currently trying to process through and find the tool. And once that number finishes and completes, that means it's been successful. So in my case, that means pandas is already installed on my computer, right? So how is that if I never bothered to install it? Well, this is just another reason to thank Jupyter Lab Desktop. Many versions of Jupyter Lab Desktop, though this does vary, right, come with the common data package science packages that many programmers use pre-installed. And their goal is just to make it easier for you or me to get going and for beginners, right? So we can thank them at this point, but in many other circumstances, and maybe in your circumstance, the tool is not available, right? In that case, you have to install pandas yourself from the Python package index. And there's multiple ways to do that, but one common one is to do an exclamation point, the term pip, which is the Python installer tool, install, and then pandas or whatever other library you'd like to run. If you ran a command like this, waited for it to finish, and then reran the import, it's almost certainly then going to work because now pandas has been repackaged, right? Now, there's an alternative way on some computers where if the exclamation point doesn't work, you try a percentage sign. This is advanced Jupyter stuff that I won't pause to install here. But if you're not seeing pandas installed, I would advise you try running a cell that says exclamation point pip install pandas. If that doesn't work, try percentage sign pip install pandas. If neither of those work, you can go ahead and chime in the forums or leave a comment on the video, and I'd be happy to try to help you. The answer might be available for you in Google, but I suspect that one of these two things is going to work along the way if you don't have pandas already installed. So now that pandas has been imported, the term pandas is in effect a variable like any other variable, like the very simple ones we made in our first lessons. So if I type the word pandas and I run a cell, it just prints out for me the location of the gigantic chunk of code that is the pandas library. The big tool belt with the hundreds of different tools starts as it is available in this directory on my computer. And printing it, all it does is tell me where that is. But this variable has within it the power to access those tools. And the way you do that is after by typing the variable, you type a period, and then I hit the tab button, and this is another piece of Jupyter magic. If I hit period tab, I get an autocomplete option that that most other code editors don't give you. And here we see a first glance at the many different tools that are available to us on the pandas tool belt. And this is only scratching the surface, right? And they all follow from us having typed pandas dot whatever it ends up being is how we're going to access those tools, right? And so writing pandas code and taking advantage of the tool belt involves again and again, over and over again, typing pandas dot this, pandas dot that, depending on what you're wanting to do. And even though the word pandas is only 6 letters long, typing pandas dot this, pandas dot that got kind of old, even to the people who invented pandas. And so they wanted an abbreviation. They wanted a way to access their tool belt that was just a little quicker, that didn't require writing so much code. And so they came up with a nickname or an alias for pandas of PD. And so almost all Python code you see that writes pandas is going to start with an import like this at the top. Import pandas as PD. And all that's doing is renaming the variable, which has to be imported with this long name because that's the name of the folder where it's stored. It's just renaming it with this shorter nickname so that it's quicker to access. In the same way that my name is Benjamin if you were to look at my birth certificate or my driver's license, but I go by Ben. It's just easier. It's the same thing. So if we type import pandas as PD, hit play. Now if I do PD dot and then tab, we can see all those same tools are now available, but we only had to type 2 letters. And there's nothing magic about the alias PD. It's entirely a convention, not a law. They could have named it P. They could have named it PA, right? They just chose PD. I don't know why, but I'm sure there's a story among the inventors. And this has become kind of a popular convention that is just widespread. And if you're going to become a pandas person, it's good to get familiar with it so that you're able to read other people's code and other people can easily read your code. So now we have pandas installed and ready to go. So let's look at an example of how that tool belt might be useful. To start with, let's repeat something we did earlier. Let's make a variable called my_list, flat bracket, and let's put those even numbers between 0 and 10 in there again as sort of a simulated data set, right? So my_list equals 2, 4, 6, 8. And I hit play. So now we have our sort of simplified simulated data set, and it's saved in this variable. And in the last lesson, we saw all the basic stuff that Python can do with it. But pandas can do so much more with much, much less code. And so the way that you sort of are able to take advantage of the shortcuts of pandas is you have to introduce your data set, wherever it might be or whatever format it might come from, to pandas. Pandas has to read in your data set, as an input so that it's able to give you back a pandas tool that's easier to work with. And in the jargon of pandas, any list of numbers or column in a spreadsheet is known as a series. And a series is just the catchy name that they decided to give a column of data. It's if you type PDSERIES, like this series, right? And then open parenthesis, you pass in my list, close parenthesis. So this is very similar to what we did with sum and len earlier, right? Where we passed in our variable to a set of parentheses or a function that's going to return something else. And so if we pass our list into the pandas series and hit play, we can see it doesn't just output 2, 4, 6, and 8. It outputs this little data table of readings. There's 2, 4, 6, 8. And to the left are what are known as the index. And this is just a counter that's telling you this is the first item in the list, the second, the third, right? In computer programming, for whatever historic reason, whenever you count upward the items in a list, the first item is always the 0 item. Then the counting begins with 0. And so the index of the number 8 here, even though it's the 4th number, is actually 3 because the count began with 0. This is a oddity of computer programming that you'll see in almost every programming language. It won't affect us in the course of this class, but it will, if you stick with it as a programmer, it will play an important effect on some code you write in the future. So it's good to always keep that in mind. And so now that we have our data as a series, if we hit the period or dot after that and hit tab, again, we would have access to many, many, many more superpowers or tools that are available to a series. But before we can access those, we need to save our work in a variable so we can use it in subsequent cells. So instead of calling it my list, I'm going to call it my_series. I'm going to save to that variable with the equal sign. And then what's going in is the series method being passed our list. And so now my series is saved as a variable and can be reused. And among the many tools available are a lot of the basic descriptive statistics that we started to scratch the surface of last chapter. So for instance, if I do my series.sum, boom, that's the exact same as before we did sum my list. You may remember that from the last chapter. This is the same operation. And so this is Panda's way of running a sum statistic on a list of variables with a very small amount of code. Now, in this case, that's not very much of a difference, but you'll see not only does it become much shorter later on, and not only does the code run faster, which is a whole more complicated Python thing, It also will have access to many, many features that built-in Python doesn't have at all. So we do my series sum. That's one basic descriptive statistic. You can also ask it to get the maximum value, right? If you think about our basic stats with dot max gives you the biggest number in the list, which is 8. My underscore series dot min gives you the smallest number in the series, that's 2, right? Remember before when we calculated the average, we had to do the division ourselves and we had to do sum divided by length? Well, the nice thing about a series is I can just ask for the mean, which is another word for average, and I don't have to do any math myself. It just did it for me, right? And not only can it do the mean with less code, it can do the median, which we were unable to do with our other Python code, at least as quickly. And so if I do dot median, boom, the median is printed out. And you can see there that we've just run 5 different descriptive statistics with very, very short and quick lines of Python code that didn't require anything more than getting our data into a series and spitting out the results. There's a lot of other ones you can run it to, of course. Standard deviation has been unfortunately, abbreviated as STD. You can get the standard deviation. There's even a nice kind of report card function called describe, which will print out in one little report a whole bunch of things. It gives us the count, the mean, the deviation, the min and max. Hey, there's the median, that 50th percentile, but we get a couple other percentile figures too, right? And so just getting your data, kicking it around, getting back some really basic stats becomes really quick. Even though this is a very simple data set, right, the principles and the code itself would be exactly the same if we had not just 4 numbers, but if we had 400,000 numbers or 400 million numbers. However big this list gets with numbers, the code's going to end up being exactly the same, right? And it won't even take that much longer to run. So to illustrate that point, we'll do as we did in the last chapter. Everybody go to your list and insert the odd numbers between 1 and 10. You can then run all cells from the run menu to run the entire notebook again. And we see that, hey, that's all changed. And everything is now the odd calculation. And to sort of solve the issue we encountered last time, go ahead and add a gigantic number to your cell. There's 999. Herman Cain's favorite. Run that from the top, and we see, yeah, we've got that large average, same thing we did last time, but look, the median's already been solved for us without us having to do any extra work. And so a really nice example here of how we sort of rewrote our analysis using pandas instead, and it ended up being, less code and having the ability to do more stuff. And that same principle is what we're going to follow as we continue on in this class, which is just exploring pandas to help us do more and more with data, right, with less and less code, so that we can really quickly write cells that ask and answer questions as we interview a real-life data set. And that's what we'll start in our next chapter, when we're going to put these little simplified fake data lists aside, and we're going to bring in a real data set from an investigation that I published in the Los Angeles Times. Look forward to seeing you there.